Hi, this is Matis from Blue Guardrails, and I want to walk you through the making of our RAGTruth hallucination benchmarking dataset. What's a hallucination benchmarking dataset? Well, you all know that large language models hallucinate, even if you feed text into them. So even in a RAG application or an agent, your AI model might generate outputs that are not based on the inputs, and they are hallucinated. So to capture how often these models hallucinate, you can use benchmarks. Benchmarks where some other model detects if an output is true and grounded in the input, or if it is a hallucination, in fact. And these models, of course, they also need to be benchmarked. So kind of who's watching the watchers. And for this purpose, there's a data set called RAGTruth, where people basically took a bunch of inputs, question answering tasks or summarization. So asked a large language model, hey, here's a news report, please summarize it in a couple of hundred words. And then the model produced a response. And then humans went and marked up the text and said, oh, actually, there's a hallucination here and here and here. And we used that benchmark early on to kind of benchmark our own hallucination detection methods. So how many of those marked up hallucinations could we find using our automated hallucination detection? And at first we were like, wow, that's not great. It doesn't really conform to what the humans have said on that data set, and oops, that's a problem. And then, as any good AI engineer should, what we did is we dug into that data pretty deep, and we looked at all the error cases. So where the benchmark said, this is not a hallucination, but our model said, oh, it's actually a hallucination. And we found pretty quickly, just like going through very few examples, that our model was right most of the time, and the human annotation wasn't, or they missed the hallucination in that case. So what we did is we went ahead and we said we need to completely revamp this benchmark. Like there's too many errors in there, and we cannot really use it to validate our own methods. So what we did is we used an automated approach, our automated method, to label a subset of the RAGTruth dataset, and then to really be sure about the quality, we followed it up by a two-way independent human review. So Miriam and I went through all the data. We built a small annotation tool to label the hallucination spans, and then went through that. Hey, this is a hallucination. This is a hallucination. Oh, this is actually not a hallucination. Our method wasn't right in that case. So we did that once for a chunk of data each, and then we switched chunks and did it again, each for that chunk. So that's a two-way review of our model-based predictions. And then we also sat down afterwards and looked at, hey, now we have still some chunks some hallucinations where we don't agree. And we went through them and clarified them, and then ended up with a bunch of hallucinations in that data set, or a bunch of marked up text parts where we knew the original models actually hallucinated. And our agreement was quite high, so we measured the F1 score between the two of us. Was around 80%, which is quite good. So that meant our our annotation guidelines made sense. And with the additional step of reviewing everything together, we created a higher quality data set. Now, the results are quite astonishing because the original RAGTruth dataset on the about 400 responses that we labeled, they found 86 hallucinations. So they said in 86 of those 408 messages, there is a hallucination. We actually found 865 hallucinations. So multiple hallucinations per message, 2.1 on average per message, per response. That's a 10x difference to the original data set. And what surprised me the most was things like in the original data set, GPT 3.5 and GPT 4 barely had any hallucinations. So I think for the subset that we labeled, I think they detected one hallucination for GPT 3.5 and 0 hallucinations for GPT 4. Now, when we come to our data set, we actually found that about 50% of the responses generated by GPT 3.5 and GPT 4 do contain hallucinations. And that's a lot. So while these models might be a bit older, the original data set is from 2023, we think it's still very relevant to see that models that back then at the time people thought, oh, they're not hallucinating that much, maybe 3.5, but GPT-4 people said, I still remember that, oh yeah, we solved hallucinations. And then it turns out they didn't. GPT-4 actually had more hallucinations than GPT 3.5. So yeah, that's everything about the dataset. We are calling it RAGTruth++. We are releasing it open source. We're putting it on Hugging Face. I'll put the link in the description below. So you can check it out and benchmark your own hallucination detection systems against it. Excited to see what you create from it, what you can build with it. And thanks for tuning in today.